Today, we're going to talk about lessons learned automating the incident lifecycle within the context of SOC. But first, I want to make a quick introduction. My name is Alexander Sinno. I'm the head of the Inviso Fusion Center operations. I have some experience building security operations centers out in the Middle East. Previously, I used to work for the largest MSSP in the world, known as Dell SecureWorks, as a senior intrusion analyst. And before that, I was in the United States military as a fire support specialist. And I would like to also introduce my colleague who's a co-presenter with me today, Walter Stinkens.
Thank you, Alex. I'll also quickly introduce myself. My name is Walter Stinkens. I've been working at Inviso for 4 years. I have a background as a DevOps engineer and in cloud security as a DevOps engineer. Big part of your work is automating stuff, and that's also what I've been doing as the SOAR engineering team lead at Inviso.
All right, thank you, Walter. Just before we dive into the cool stuff like the automations and those sort of things, we should break down the perspective of why automation is so important. Now, when you look at the traditional SOC, each analyst, they have about 20 minutes per security event, or 20 minutes to handle a security event, right? Now, those numbers actually add up quite a bit. Most of the time, a SOC analyst can actually handle a maximum of 25 security events per day. And the big problem is, okay, we have a huge lack of personnel worldwide. So how do we deal with that? And we know that from our experiences, that automation is key. Now, we took a 7-day time span and we calculated that we ingested 647 security events. And if you use the math that we displayed above, that would take about 26 analysts to handle all of that. So you do the math on what type of a cost that is. And now just for you to have 24/7 alone, without factoring in all the security events, you need about 12 analysts. Now, when we saw those numbers, we decided immediately to start automating and start assisting the analysts with automations. The first thing that we saw is that our automations actually decreased the analytical workload by 97.42%. Of 5,790 alerts that we took in that time period, only 145 were manually analyzed in 7 days by the SOC. This reduced costs down to 1,483 euros as opposed to 59,251. So the math is there and it makes a lot of sense to handle it this way. Now to explain a little bit about why this is important and why it's so effective, let's look at the traditional SOC. So in the traditional SOC, this is what you would have. You would have isolated components, none of them talking to each other, none of them working with each other. So everything in a different silo, which increases the number of clicks for an analyst to resolve an incident to find the information that they need significantly. And it makes them less apt to going into all those individual devices at the end of the day in order to find the information that they need. So what do we do to solve that? We use a security orchestration and automated response platform called SOAR, and we do a lot of development on top of it. And that way we can actually work with all the different components without actually having to go to those platforms. So we assemble all of the data into one spot where SOAR will become the central nervous system of your entire security operations center, and all of the capabilities that are available for your analysts will be built into one platform. So isolating machines, running antivirus scans, resetting passwords, revoking sessions, making a phone call, getting information on what ports are open on a specific device, getting a reputational analysis from VirusTotal from your threat intelligence feeds, all in one place for the analyst and just completely handled by automation and presented to them so that it actually takes the analyst significantly less time to handle an incident because they have a hell of a lot more context to work with. So these are all important factors. So not only just automating from the entire events, but also reducing the amount of time and effort that it takes an analyst to make a conclusion on a particular security event. Now, just to go through a bit about the incident lifecycle and the way that we manage it here at Inviso. So we built something up at a high level. The first step is triaging. So we build our integrations into the SOAR platform. We only pull in from the security end products, such as the EDR and the SIM. And what we do, when those are ingested, we immediately start enriching those events with other various types of data. So, for example, we'll take all of the IP addresses, all of the hashes, all of the user accounts, the hosts, and we'll start converting those into indicators of interest. Those indicators of interest are actually stored in a panel for the analyst for them to be able to see all the relevant information that they need. Now, in a lot of cases, we even store data inside of the indicators themselves. So when we extract a phishing email, for example, that entire phishing email sample is actually laid out for the analyst inside of SOAR. So no need to jump all the way into another tool just to see the layout of a phishing email. So taking it maybe 1 minute just to analyze a phishing event now, as opposed to 20 or 30 minutes per each phishing event, because you got to jump into, 1 or 2 different platforms to do that. Now, the second step is the incident management portion, right? This is where you classify events. This is where you decide how you want to notify people. This is where you want to decide if this should go to an analyst right now. And it does a hell of a lot of filtering. And then it goes into the analysis phase. The analysis phase, we try to do as much automation as possible without adding additional risk onto our customer base or into any of the customer environments. So we don't automate where it's not practical and not wise to do so. Now, basically, a lot of the full automations that we do are checklists that analysts would do anyway, so they're manual steps that we fully automate. One great example is called the access anomaly classification, which we've built. And from that, we're able to fully automate the analysis of an impossible travel activity, and we can do it significantly faster than a human being. And most times, it's either something interesting or a compromised account that comes in. So when that is done, we then notify the customer through ticketing, through phone calls, through other various methods. And then we determine, do we need to destroy the actor now? Is there something in here that we need to do? So again, do we want to revoke a session? Do we want to isolate a machine? And how do we give those tools to a SOC analyst so that they can start taking action now? And these components is what makes a traditional SOC, or it's the difference between a traditional SOC and a future SOC, which is built on orchestration and automation. And those are very, very key elements. Now, from here, I'm going to hand it back over to Wouter, who's going to talk a little bit about SOAR development.
Okay, thank you, Alexander. As Alex said, I'm going to dive in a bit deeper in how to do the SOAR development. At Enviso, we've been using XOR for more than 3 years now, and we're currently on our 3rd generation of the automation stack. We use Cortex XOR as an automation platform, and there you have 2 concepts to actually create your automations. One is playbooks, which is drag and drop programming, so you can actually define your complete automated workflow without writing a single line of code. And you have automations. There you can actually host your own Python code and do everything in there. In our generation 1 and generation 2 playbooks and automation stack, we actually had the principle to do everything within playbooks. Why? Because we wanted our engineers to be able to create those playbooks without needing to know Python. But from experience, we've learned this had some disadvantages, mainly performance. Here you can see a table with how long it would take for us to only do enrichment with playbooks in our generation 2 and our generation 3. And by doing as much as possible actually in Python code, we have improved the performance by almost 100%, which is, from a performance perspective, insane to do it like that. Currently, running our entire playbooks can be done at least under 1 minute, but we'll show you that at the demo at the end of the presentation. One of the consequences of actually doing as much as possible in code is that, it becomes a development project. And this also means that you have to implement some of the principles you would do when doing development. With my background as a DevOps engineer, I did a lot of these things. So the things we actually implemented is things like test-driven development, deployment pipelines, and all of these things. And one of the important things that we implemented to structureize actually all of our development effort is we started using the Scrum methodology. Scrum is actually an agile development methodology which allows you to structure your development efforts. In the beginning, when we started using XOR, we were just two guys developing playbooks on our production environment, and the requirements weren't clear. We just, we had daily calls with the SOC manager, Alexander, and we were just implementing stuff, and we were just going. When you do this with two people, it's kind of manageable, but now we've grown our team into 6 SOAR engineers who are dedicated, who just write automations the entire time. Well, if you grow your team, you need a better methodology. With Scrum, Scrum actually requires you to first define all of the requirements for development as user stories. Everything needs to be clear what you need to develop. And once that's clear, you need to plan it. And the nice thing about Scrum is you can incrementally improve all of your processes. At the end of each Scrum sprint, within Scrum you use a sprint of 2 weeks where you plan all of your development tasks. At the end of the sprint, you do a retrospective meeting where you actually reflect on the previous sprint to see, okay, what went well, what didn't went well, and what went better. We've been doing this for almost a year now, and you really see that we have been able to produce much more. We have been able to do a planning because in the beginning it was impossible for us to commit to our customers, okay, this is when your feature request will be delivered. That's something we can actually do now because we have an insight on how many development tasks can we actually do within one sprint. And also when you do development, some other things actually are also really important. First of all, put everything into version control to make sure that everybody's working on the same code base. It's a very important one. Don't develop on production. You would think that's logical, but that still happens. We have a development, testing, QA, and production server. And we use our version control to move everything between those servers. All of our code is on GitHub. We use pull requests between different branches. Those pull requests need to be reviewed by somebody else who developed it, and all of those things. So when you start doing this, treat it as a development project. Implement the same principles as you would when developing software, basically. That's a very important one. So now to the interesting part, we're going to show you a demo. The scenario of the demo is first we're going to show you the end user perspective. The scenario is the CEO opens a malicious document on his laptop. And first we'll show you the end user perspective to show you how long does it take for our automated remediation actions to be applied. And then we will show you how this all looks in XOR and how this exactly works. First we'll show you the end user perspective. This is the laptop of the CEO. We're going to show you exactly how long it takes. So let's start the stopwatch and execute the malicious document. Now we have Cortex XDR installed as the EDR tool, and after 39 seconds, it has already detected that something malicious has happened on the laptop. This alert will now be ingested into XOR. And our analysis playbooks will determine that the threat is actually the malicious document has been allowed to run, and it would automatically execute a vScan. So here you can see after 2 minutes after the alert has been generated, a vScan has already been executed. The second remediation action that will be executed is a machine isolation. This is a semi-automated process which requires an approval from a senior analyst. So depending, of course, on how long the senior analyst takes to approve it, the machine will be isolated. So here you can see that after, in total 4 minutes, the threat has been detected, remediation action have been taken, and the threat has been contained. So how does this look like in XOR? Here you can see the XOR interface. And this is one of the dashboard. This is actually the dashboard that the analyst looks at every day. So if a new incident comes in, it will show up in this dashboard. XOR pulls alerts every minute, so we can take up to 1 minute before the alert is actually in our SOAR platform. So let's refresh this dashboard until the alert is there. Okay, there it is. This is the alert. Let's look at the playbooks that are being executed. It's already on the analysis playbook. Okay, now it's already on the notification playbook. And because this is the laptop of the CEO, which is defined as a critical asset, a different escalation path is actually followed. So our analyst will get a phone call because this is a critical alert.
Security alert from the NVISO Security Operations Center. This is a severity alert for wildfire malware, laptop CEO. Press 1 at any time to acknowledge this alert. To hear more details, please press 2. Thank you for acknowledging this alert.
So that's actually the call that our senior intrusion analyst will get because this is a critical severity alert. And this is a call chain that, well, if somebody doesn't acknowledge it, it will go to the next person. So now we can already see all of the remediation actions actually have been executed. Well, we'll see how this looks like. Well, maybe first of all, I'll show you the interface itself. This is the interface of XOR. What you can see here is on the left, you can see all of the case details, the severity. Okay, it is a critical asset. It's not aggregated. The incident is, the outcome is allowed, which means that the threat has not been blocked. Here you can see the investigation data, so what the result of the analysis playbooks were. So here it says the threats were detected, but they were not all contained. Here you can see all of the indicators which are actually in the alert, in the incident. So all of the hashes, the sample, which user account, which host, all of these things. Here you can see the actual malicious document that got executed. And we also try, we ingest alerts from different SIEMs and we present a unified interface, just one layout to the analyst. That doesn't matter which source product actually the alert generated. So in the remediation tab, here you can see all of the available remediation actions. Here is a list of the ones that have actually been executed. So here you can see, okay, a scan is pending, and the isolation, that's pending approval. So this actually requires approval from a senior analyst. So what they need to do is first click the load button to see the approvals. Then they have to approve it and then submit the approval. Here you can see, okay, the status, approval status is approved, and now it's waiting to be executed. And this actually runs on a job on the background, so that, okay, here you can already see that the machine has been isolated. So this is actually how this looks like in XOR. XOR allows you to completely customize the interface, which is really nice. This is a completely custom tab that we created ourselves. And with the automations on the background, you can actually run all of the Python code you want. So it's a very flexible platform, and this has allowed us to actually automate as much as possible in our SOC. Okay, so that was the demo. Would like to thank you all for viewing this presentation. If you have any questions, you can find us on LinkedIn. Well, hopefully you guys found it very interesting.